Let's get started. Thanks for coming for my talk today. Today we're going to talk about Hadoop Yarn, present and future. You must have heard a lot about Yarn in the last few hours. I'm Vinod Pavilapalli. I work at Hortonworks, and a quick show of hands before we get things started. How many people here have deployed Hadoop 2 or used Hadoop 2, as opposed to, that's quite a bit of number. So a quick run through of who I am. I'm Vinod. I work for Hortonworks. I'm 6.75 Hadoop years old. That's a new metric for age. And the reason why I put that here is, I keep getting these emails about 10 years of Hadoop experience. So we're not there yet. The last thing at school, I was managing a 2-node Tomcat cluster, and I was very proud of it. 3 months later, I was in the midst of a major meltdown. I brought down an 800-node cluster, so that was quite something. Yeah. So, like I said, I was previously at Yahoo, part of the Hadoop team, and I'm now at Hortonworks. I wear 2 hats. One is the Apache hat, where I'm a committer, part of the PMC, and I also wear the Hortonworks hat. So I'll keep juggling between those hats here. Please bear with me. I worked on Hadoop MapReduce in Hadoop 1, security, capacity scheduler, and then finally when we started Yarn, I was working on it full time. I then worked a little on Ambari to get it off the ground, and then recently I worked a little on Stinger. I now lead the Hortonworks Yarn development team, which is a small team. I've done a lot of troubleshooting on clusters. I like debugging, and specifically in a distributed setting like Hadoop, it's pretty challenging. It satisfies me. Most of the code, about 99%, it's there in Apache, which is both a good thing and a bad thing. Bad thing because if somehow I get kicked out of this, I would not know what else to do. Anyway, so that's a quick rundown of what I am and who I am. So the agenda of today is I'll give a quick overview of Hadoop 2. I'll not spend a lot of time describing what it is. I get a sense that most of the people here know a bit or two. I'll quickly, cover what's the current state of the project, what's the future state of the project. That's the major focus of this talk. Before we start discussing the present, let's quickly jump through a brief introduction of Yarn. What is Yarn? You've heard the data operating system word. You might have heard it a few times in the morning keynotes. Yarn is the resource management platform that enables the data operating system, right? It's the core of the data OS. On top of Yarn, we have MapReduce v2 running. And beyond MapReduce, because Yarn has solved a lot of these common problems that are faced by every application, we now have a plethora of new applications coming up, like Tez, Storm, Spark. All of them, they run on top of Hadoop on a single shared cluster of machines. And it's not just a regular MapReduce-like MapReduce or Tez-like applications which finish after a while. We also want to support long-running services, right? The goal is to share the underlying cluster of machines, the physical resources for any type of application or workload that you can imagine. Now, how is it different from Hadoop 1? At the top level, Hadoop 1 primarily comprised of HDFS and MapReduce. And MapReduce itself was doing a couple of things. One is managing the cluster, what happens when a node goes down, what would I do if some of the disks fail on a machine, or a task failed because of either user error or a system problem. And how do I execute the MapReduce DAG itself, right? Run the maps, run the reduces, do them one after another, try to pipeline them, look at the jobs from multiple users, all of that, right? Now, again, this is a dead horse that is beaten a lot. Hadoop 1 was primarily built for batch apps. It was pretty hard to evolve it beyond just doing batch applications, right? And that is what Hadoop 2 really solves. We have HDFS 2, which kind of is a major evolution of HDFS 1 itself, and with a bunch of very useful features. On top of that is what we have, Yarn is the cluster management solution. On top of that, we built MapReduce, the traditional compute platform, and then everything else that came after Yarn. Now, if you see this, certainly Hadoop is no longer centered around the batch applications. We enable streaming applications, interactive applications. Think of a workload type. It can actually run on top of Hadoop now. So to quickly summarize what the key benefits of Yarn, benefits as well as requirements when we originally started the project. Any application that you could think of, it's easy to get it running on a single machine. The real challenge is to run it at scale and in a seamless fashion. And one of the key goals of Yarn is to enable that. And like I hinted before, we do not want to restrict ourselves to a single paradigm of computation, right? We want to enable MapReduce, MPI, graph processing, stream processing, all sorts of those things should be able to be run on top of Hadoop. And that was not the only goal, right? We wanted to enable all of that, but we did not want to sacrifice things like performance and utilization. And as I'll show in the next few slides, Yarn has enabled lots of users to better use their cluster hardware. And so two other things. One is agility. In Hadoop 1 world, if developers see a bug or users see a bug in the MapReduce, the logic of how you execute a MapReduce application, you essentially have to bring down the cluster, fix the bug, update the bits, and then bring it back up. So whether it is a cluster issue or whether it is an application-specific bug, you have to actually replace the whole thing, right? So it is not a very agile way of doing things. With Yarn, if there is a cluster, if there is an issue with the cluster management software, you just replace that. If there is a bug with MapReduce algorithm or a graph processing algorithm, you just replace that specific application, which kind of enables a lot more agility. You can even imagine running MapReduce 2.0 and 2.1 and 2.1.2. They all can run on the same, in the same cluster without affecting everyone. In the Hadoop 1 world, if you have to update MapReduce, you'll essentially affect everyone, right? Some of the users may actually don't care about a new feature. They may not care about that bug, but everybody will be affected. It's a lock-in step evolution of upgrade of the cluster. And the last point is we do not want to build Yarn for yesterday's use case. We're looking at the evolutions in hardware. 2 or 3 or 4 years back, memory was one of the biggest bottlenecks. Now you take a commodity machine, you have anywhere from 128 GB of RAM to, I've seen places where people are putting in 500 GB of RAM. So RAM is no longer a scarce resource. On the other hand, disks have, the best you can get today is 12 disks and 3 terabytes per machine. So hardware is evolving at a rapid pace, and we did not want to build Yarn for yesterday's use case. We wanted to build it for future, right? So those are key benefits, and there are a bunch of people who have deployed Hadoop 1, and this has been a topic that comes up time and again. Why should I migrate? Hadoop 1 is good enough for me, right? I've talked about utilization, performance, ability to run alternative paradigms, and stuff like that. If you don't care about any of those, even if you just wanted to run your old MapReduce jobs or big scripts or Hive scripts, we just move to Hadoop 2. You'll get a lot of performance improvements. So Hadoop 2 is, at least twice as good as Hadoop 1 with respect to that. Even HDFS has a bunch of features. I'm going to talk about a few of them. And the improved performance, what it really does is you can make better use of your hardware, right? I'm going to give a few examples from pretty large users. The first one is Yahoo. So they're the most of you might already know, they're the leaders and the forerunners of all things Hadoop, right? They have deployed Yarn in production throughout all their clusters, and they're moving fast towards 2.x. 23.x is a branch where Yarn was first committed in Apache, and this is a mind-boggling number. What they've really seen is they have the biggest cluster at that point of time before Yarn happened was around 4,000, 5,000 node clusters. In the same environment, because of the improved utilization and performance, they could cut down the number of nodes. So their largest cluster is no longer the largest cluster as before. They reduce the number of nodes, but they can run more jobs on a smaller cluster. And that's really mind-boggling, right? They were not using Yarn for anything other than MapReduce at that point of time when they deployed the first cluster. And they've run, this statistic was an year ago. I'm sure this is outdated. They ran about 14 million jobs on a given day. And the numbers are completely mind-boggling. Continuing that, Twitter also has recently updated that they've deployed Hadoop 2 in their production clusters. They're using Federation for HDFS. They've run a couple of millions of jobs. So that's in their validation. The big difference from Yahoo and Twitter is that Yahoo is still on 23.x. It's close to 2.x, but it's not the same bits. Excuse me. Twitter is actually, it has deployed, they've deployed the Hadoop 2 bits themselves. That's a good validation that we haven't regressed from what we were in 23 release line. And finally, eBay, they are one of the largest. They have one of the largest clusters with multiple tens of petabytes of data. And they've recently migrated from Hadoop 1 to Hadoop 2. They also see huge improvements in their utilization. They have a slightly different user base compared to Yahoo and Twitter. They have, their users are using different sets of application frameworks. And across the stack, they're seeing that they're getting a lot of utilization improvements. And there is a talk by Mayank. You definitely want to go there. He'll explain what they're seeing, why they're seeing, and kind of validate the promise of Yarn. So to summarize that overview, Yarn is this core of the data operating system. You might have seen this multiple times. We have MapReduce working on it. We have Thales, things like streaming via Storm or Spark. And it also suddenly opens up a lot of the underlying APIs so that users themselves can write their own frameworks, which they could not do in Hadoop 1. So that is another big advantage, right? So I'll now jump to the what's the current state of it. This is not a futuristic talk where I'm promising you things that'll come in the future, right? So as you have seen, most of the users have deployed. They're running Yarn on a few of the big clusters. And so I'm going to now quickly walk through the release lines, how they've evolved, and what features got added over time, and stuff like that. So the first GA release of Hadoop 2 was 2.2. It happened last year in October. And that was the first release when we officially started supporting Yarn APIs. The Yarn APIs, the low-level APIs that I'm talking about, on which MapReduce, Thales, Storm, they can work on top of. They were going through quite a bit of churn. So Hadoop 2.2 was when we stabilized those APIs and said, hey, these are the APIs that we're going to support for a long, long time, right? And more importantly, we wanted to make sure that the existing users of MapReduce and Pig and Hive and all the ecosystem projects that were happily running on top of Hadoop 1, they have a pleasant experience on Hadoop 2. So we spent a lot of time making sure that all the APIs in MapReduce are binary compatible to MapReduce 2 on top of Yarn. And because everything else is built on top of Yarn, we have made sure that Pig and Hive and Uzi and Scoop and cascading, scaling, all of those things can happily work on top of Hadoop 2 without any visible change to the end user. That was the primary goal, right? Users, the more pain we expose it to the end users, the less adoption we get with Yarn. So that was a major effort, and that helped a lot of these guys that I talked before help move to Hadoop 2 faster. And we did a lot of performance benchmarking efforts to compare how MapReduce was running in the Hadoop 1 land and how it's running in Hadoop 2 land, and make sure it's either better or or on par with what was running in the Hadoop 1 world. I will also talk a little bit about some of the features that are in HDFS. I'm going to talk about them because they're quite relevant to why, if you look at them in conjunction with what's happening in Yarn, you will get a feeling of why they're all going in that step. So if I go to specific examples, then you'll better appreciate them. So fundamentally, in 2.2, we had high availability for HDFS. HA has become core concerns for a lot of organizations across the stack, and HDFS happened to be the first component which implemented HA. We also have federation. Twitter started using federation, which is a way of splitting your namespaces for scalability. There is HDFS snapshots and even NFS access to the data that's living inside HDFS. This fits into the enable apps, not just regular MapReduce applications, right? We also announced support for Windows, and we did a lot of testing, which I kind of already hinted to. The next release that happened was 2.3. That was in February of this year. That was the first release that happened in this year. Yarn did not specifically add a lot of things after the API stabilization effort. Some of the efforts like Resource Manager HA, Application History Server, which I'm going to talk in the 2.4 line where they really became stable. And HDFS added a couple of very interesting and important features. One of them is the heterogeneous storage. Historically, HDFS looked at disks, and it basically was managing a bunch of disks and putting data on those disks, right? And looking at all these new applications that are coming on top of Yarn, HDFS actually had to evolve beyond being just a disk-based system. Now, after this feature, you can support, HDFS is in a position to support SSDs, any type of storage system as one of the recognized, storage piece on the individual node. The next important one is the data node caching. A lot of in-memory frameworks sprang up on top of Yarn, and to enable them, achieve their performance or performance goals, data node itself had to be enhanced to start supporting in-memory data sets. And the way it works is, today, at least, users or admins have to talk to the name node to start pinning up some of these data sets in memory. And applications like MapReduce, Hive, they can use those data sets directly by reading it from memory. And most of this is outside of the data node's heap itself, so that has a good side effect of not affecting the data node's regular operations. The next one is 2.4. There is a release vote that's happening right now. This is, again, a big release where we're going to support Resource Manager restart, failover, which I'm going to talk a little more in detail, and preemption and application history. In HDFS, we've added things like rolling upgrades. Rolling upgrades is another feature that we need across the stack, and HDFS happens to be one of the first few components which implemented it. And we also implemented, the HDFS team implemented file system hackles. So I'm going to talk a little bit on the Yarn features. So if you look at Hadoop, Yarn's architecture, the goal had been to be better than how Hadoop 1 was, right? And in Hadoop 1, if there's an issue in the cluster because of which you have to bring down the job tracker, clients are essentially forced to resubmit everything. That went away with the Hadoop 2's architecture, but because of our priorities, we had to do the real RM restart and failover work later, and that's finally coming to fruition in 2.4. So after 2.4, if Resource Manager goes down for some reason, you admins will configure and keep a standby that's running all the time, and either because of network issues or because something happened on that machine, if the resource manager goes down, the standby takes over, reads the state that was written by the previous resource manager, and it'll continue to operate. Right? The clients, the node managers, they'll all be seamlessly redirected to the new resource manager. So the end user should not see any impact other than a 5-6 second blip in the throughput of the system. And then there is capacity scheduler preemption. Before this feature, if a single queue had multiple users going in one after another, the scheduling algorithm in capacity scheduler is first in, first out. So the first guy who arrives into the system, he can potentially take over the entire queue, right? And if those tasks don't finish for a long time, the next user in the system, even though he has he's guaranteed his share of the queue, he cannot get that capacity till the tasks or the containers in the previous application finish, right? With preemption enabled, you can control how fast the containers can be reclaimed back from the previous application. This way, you can balance utilization of the cluster when you're the single user in the system versus you're running with a lot of users who are submitting jobs at different points of time. The final feature that we're shipping in 2.4 is the application history. Even though we've abstracted Yarn to be a general purpose system because our priorities were to make sure that MapReduce works reasonably very well, we've taken a couple of shortcuts before so as to ship the system. And one of them happens to be the job history server. The individual MapReduce application, they keep writing some historical information to HDFS, and that information is very specific to MapReduce. So those of you who know these files, they're called the job history files. You can run analysis, you can run MapReduce or Pig or Hive jobs on top of these history files and extract very useful information about how your cluster is getting utilized, how your job profiles are, how your workloads are, and stuff like that. In Hadoop 2, after Yarn, before 2.4, you could still do it, but you were restricted to only MapReduce, right? But with all these new applications coming up and some of them going into production clusters, there's a desperate need to enable the same feature beyond MapReduce, right? Our earlier story was to force the application writers to re-implement the same thing. And with this server, we have taken out the common piece and said, hey, I'll start recording all the information about these applications, basically the meta information about the applications. And then it doesn't matter whether the application itself does something specific by itself. I'll record all this information, and we are calling this application history. You can imagine running post-analysis jobs or scripts on top of this data to figure out not just how the applications are, how the cluster is. You can also reason about how much of my cluster is being used for MapReduce, how much is it used for These, and so on. That's one feature. The other important feature, again, we force people before 2.4 to write themselves is to record their current event timeline so that for the end users to really understand what's going on with their application, there needed to be a communication between their clients and the specific framework's application master, right? Now we have we have taken out that common implementation and said, we'll give you an API. While your application is running, you keep on emitting these events to the this particular application timeline server, and that way all the clients have a single unified view into the system, and each framework doesn't need to implement it. So the summary is, till now, because of the priorities, we forced users to re-implement some of this functionality that they desperately need themselves. We could live with it because there were not a lot of frameworks that are running on top of Yarn, but as more and more applications started moving into Yarn, we have started seeing this recurring re-implementation of the common functionality that's needed. So slowly we are pulling those things out and giving them APIs so that writing a Yarn application is as easy as it can be. Excuse me. So that's that's a quick run through of the present. So we talked about 2.2, 2.3, 2.4, which is happening right now, release what is in progress. So a view into the future now. We're looking at rolling upgrades. Like I talked before, HDFS has already implemented some of the important functionality needed for upgrading HDFS cluster in a rolling fashion. We are doing the same thing for Yarn, and the ideal goal here is to, like everything else, like with failover, the user should not see any impact. And anytime I need to upgrade a Yarn cluster, I do it in a rolling fashion, even on a multi-thousand node cluster, and users should not ideally see any impact. And HDFS, like I said, is already in, and Yarn, we are targeting to do it in a release or a couple of releases from now. The other goal is to enable more apps. You could argue most of the functionality to write your own framework is already there, but our view had been, our prioritization had been based on MapReduce, and we're now seeing a lot of applications which have very specific needs that MapReduce itself doesn't really warrant from Yarn. And some of those things I'm going to discuss in a little detail. One is long-range services. You want to share the same cluster to run things like HBase or Cumulo so that you share the underlying clusters. Isolation, if you run a Storm application together with a MapReduce application, you need to be careful on how you allocate them, how you isolate each of those applications, right? Storm application typically will be CPU intensive, and MapReduce will either be memory intensive or it'll be bottlenecked by the disk. And finally, we are in a desperate need for enabling multidimensional scheduling. Hadoop has had historically, like I was hinting before, memory was the scarce resource. So we had memory-based scheduling, memory-based isolation. We now need to evolve it to be to accommodate other resources like CPU, disk, and stuff like that. So long-range services, you can run them already. There's a project called Hoya, which entered incubation proposal. Incubated proposal was put forward. It's now called Slider. It's responsible for enabling any existing service to be able to run on top of Yarn. If you have HBase or Cumulo or Memcache, any such distributed application that runs for a long time, we want to be in a position where, without changing anything in the application, using this tool, you deploy it, and then it has two modes. You can run it in a standalone mode, or you can run it with Ambari. And if you deploy it with Ambari, you get all these additional things like monitoring this service, managing it, expanding it, shrinking it, and stuff like that. Strictly from Yarn, so that's Project Slider is mostly taking care of things above Yarn, how to enable long-range services on top of Yarn. Yarn itself needs to have a bunch of new things. It needs to start recognizing that long-range services are a special class of applications, because if you have given a bunch of resources on a given node for a long-range service, you can't expect those resources to be given back for a month or 2 months, and depending on how long you want to run that service, right? So Yarn needs to explicitly recognize that long-running services are a special bunch and treat them fairly. We also have other assumptions that we have made in a few places, like logs and security, where we assume that these applications finish after some time, whether it is a day or a couple of days or a week, right? But with long-running applications, we can't assume that anymore. So overall, most of the applications can be run, but we are trying to be in a position where long-running services are treated fairly and equally on the same ground as regular MapReduce/These applications. The other one is Finegrained Isolation. If you understand Hadoop's architecture, each of those nodes is it has a bunch of CPUs, it has a bunch, some RAM, and a bunch of disks, right? And containers can be from different applications, different users, and they can all be running. They'll all be running on the same machine, but they may be of different workload types. One of them can be MapReduce, one of them can be Storm, one can be CPU intensive, one can be memory intensive. There is a little bit of work here. Like I was talking, we have memory monitoring implemented, which works reasonably well. We are now moving to using C groups on the individual nodes so that you can set all of these individual resource requirements for each of those containers. We're also considering these were some of the things that we've been thinking for a long time, but we could not do before Yarn. We are considering Linux containers, or if people want real, there are some sites where they care more about isolation than, say, startup costs or some of the trade-offs that you have to make when you launch VM. So in those situations, you can even launch VM as a container, right? We want to enable admins to choose the isolation mechanism depending on their site-specific requirements. And in line with that, once you start recognizing that containers can ask for memory or CPU, we need to enable resource scheduling to recognize that there are different types of resources. Memory-based scheduling has been, again, it's been working really well. It's stable, all of that. CPU scheduling, the patch went in sometime last year, I think, but it's not baked in well. So that's the goal of future releases. And some applications also need disk-based isolation. So this is the, we're kind of going to an area where we need to decide whether we want to use lightweight containers or heavy VMs and make sure there's a trade-off depending on how much isolation you really want. Network is a sci-fi feature. There are a whole bunch of other features that in the interest of time, I cannot completely cover, but some of them are application SLAs. People want to say, hey, I'm running this application every day at 6 o'clock, and I want guaranteed capacity for that application for the next 5 or 10 minutes from 6 p.m. to 10 p.m., right? There's a requirement for node labels, and many sites, people deploy software which have specific license requirements, and maybe because of the limitations of the license or cost of the license, they can only deploy it on a subset of the clusters, right? Or they may buy a bunch of nodes with GPU capabilities, but the entire cluster may not have it, right? So some applications may specifically want to take advantage of a specific license or a specific hardware type, and that's where node labels come in. You mark individual nodes saying GPU enabled or license enabled, and applications can pick and choose which node to run on or do not run on. And similarly, there is there's a requirement to go to an individual node because of maybe its larger memory size, or because some applications like HPS, they do not want to run multiple region servers on the same machine because it doesn't make sense, right? So there is a concept of node affinity versus anti-affinity. That's one of the features that we are actively looking at. And there is better online queue management. Right now, it's very rudimentary. People laugh at it. You go edit a bunch of files to change your queue configuration and then issue a command. We want to be at a place where all the queues are managed, either centrally or decentralized. You have a UI where you go and say, hey, change this queue configuration to be in this fashion. You do not want to force admins to still deal with configuration files manually. So that's most of Yarn. A quick view into what's happening in the Yarn's ecosystem itself. I talked about a lot of applications. Each of them can be a talk in itself, and some of them have talks in this summit. There is Giraffe for graph processing. They have a mode where they can run on top of Yarn. There is Hama, which implemented the bulk synchronous parallel. They also have a mode to work on top of Yarn. Before Yarn happened, some of these projects existed before Yarn, but because the resource management layer was not common, each of them tried to re-implement the same thing over and over again, right? They were desperately waiting for something like Yarn to happen. And once it happened, they've started moving, shelving out their cluster management logic and focus only on business logic. Like if you're doing graph processing, all I really want to care is how do I execute my graph? Which vertex to start, which vertex to execute next, and stuff like that. So that's Giraffe and Hama for graph and BSP. There is the traditional Hadoop MapReduce. There is These. And there are a whole bunch of streaming applications like S4, Samza by LinkedIn, Storm, Spark, and Longrange Services like HPS and Yarn. So we know, when people ask about it, we say, first go and figure out if one of your apps if your app fits one of these frameworks before you start thinking about writing your own Yarn application, so check the marketplace to see if there's an app. If there is, you get it and start using it, right? And specifically, the reason why it's important to me personally is because I worked on MapReduce, and These is like the next generation MapReduce without all of its limitations, right? In summary, it's a processing framework which runs a DAG of vertices, unlike MapReduce where you had to wire together bipartite graphs. Like Pig generates a bunch of jobs, and each job usually writes it to HDFS. The next job in the sequence reads it back. Does some processing. Sometimes some of the mappers are really not doing anything other than reading the output from the previous stage, right? So in this example, the first one is the pig on MapReduce, right? Seems like it is processing two tables, doing two operations on the first table, one operation on the second table, and then doing some kind of a join, right? In this, it's much natural. You don't need to write these individual MapReduce jobs. You can directly run a DAG on top of Yarn. There's a talk by Sid from his Yarn and Tez PMC /committer. You might want to check that out. Excuse me. So the final summary, you can forget all that I've said. Hadoop is good. You should definitely try it for those hands which didn't raise when I was checking in the beginning. It's an exciting journey for this decade. We have done this not just to improve what was happening in the past. We thought about it with future goals, and we want to make sure that this software, if once it's deployed in your organization, it hangs around for at least a good part of this decade, right? And I've talked mostly about Yarn. HDFS also is innovating rapidly. Some of those things will be really useful for you. And, a couple more things. Arun and I, we're writing a book on Yarn. It's out in public, so you want to check that out. And then there is Hortonworks Sandbox. So if you really want to play with Hadoop 2 or Yarn, you don't need to deploy a cluster. You check out this VM. You can play with Yarn all by yourself, on a single VM, right? So the goal is to make the learning as frictionless as possible. You can use the same sandbox to either play with Hadoop 1 or Hadoop 2. So you can even do this micro benchmarks where you write a MapReduce application, run on top of Hadoop 1, and then compare it with Hadoop 2 and see how it is running so that you can get a hang of the system. So that should be it. And we have 2.5 minutes for questions.
When the CPU resource management is implemented on Yarn, it's in 2.4, it's very recent one.
So the question is, the CPU stuff, when is it implemented? So there are two parts. One is isolation of individual containers with respect to CPU, and the CPU-specific scheduling. Both are committed. They're already in 2.4. In fact, they were in 2.3 and going as back as 2.2. But they were not baked in enough, which means not tested enough to make sure it works with the rest of the system well. We hope to get it out in a couple of releases. It's mostly about making sure it's doing what it is expected to. Yeah. Anything else? Hi.
Yeah, the NFS support and HDFS.
Mm-hmm.
Who's using that? What's the kind of scenario around that?
So the scenario is you have a traditional application that may have been coded against NFS file system, and you want to enable them to move to Hadoop, right? It may not be as performant, or it may have some limitations. Off the top of my head, I don't remember the limitations, but the use case is to enable those guys to start working on top of Hadoop, and then realize that it's a good thing, and then slowly they can move over to the systems. That. Yeah. There's one there. So the question is, how important is low latency scheduling in Yarn, right? Yeah, that's a good question. with MapReduce, we did not care about it enough because typical MapReduce job would run for 5 minutes to anywhere for a day, right? But with new applications like Taze, Spark, or even MPI coming in, they have very stringent limitations on how soon they can get started, right? We recently got an Apache in Yarn itself, which does scheduling, which brings down the scheduling cost from seconds to tens of milliseconds. So it is very important for Yarn. I, as a Yarn platform developer, really want to enable all sorts of applications, not just batch applications. So it is very important. And we have Apache in, again, this. So the way it happens is, I've shown you 2.2, 2.3, and 2.4, right? Some features go in, and then they take a little while to get stabilized. So this is one of those things.
I'm sorry, that was the last question. We were ready for our afternoon break.
Yeah, thank you. If you have more questions, please try to ping me. Thank you.